Greetings and welcome to the video on measurement scales. Let's go ahead and get the title up. Measurement scales. So in general, there are going to be four types of scales. Four types of scales. And each one of these scales is going to have some properties. So I'm going to write these properties up over here. I'm just going to kind of create a list. And there's going to be four scales and really kind of three properties that I want to talk about relative to each one of the scale. And so the first property is whether or not the scale has magnitude. The second property is going to be whether or not it has what we call equal intervals. And the third property is going to be whether or not it has absolute zero. Okay, so magnitude is just talking about whether or not this particular measurement scale is greater than or less than, whether or not you can say greater or lesser relative to another thing that's being measured. The second one, equal intervals, well, it kind of makes sense, is that the distance between a 1 and a 2 is the same distance between a 2 and a 3. And absolute zero means that you have an absence of whatever you're measuring when you get to zero. And we're going to talk about this as we go forward. But let's just kind of jump into it here. So the very first scale I want to talk about is going to be the nominal scale. So the nominal scale is really our most rudimentary scale that we have out of the four measurement scales, and really all this is just kind of numerical naming of things. We're using numbers to name things. So we're going to group objects into classes or categories based upon numbers. So for example, what is an example? Let's say we have a variable, and that variable is x, and the variable x really, if we wanted to name it, maybe it's sex, biological sex. And under this, we're going to have two levels to that variable. You can either be male or you can be female. And so we simply just assign a 0 to males and a 1 to females, or we could assign a 1 to females and a 2 to males. The number doesn't mean anything other than it is classifying them into categories. So therefore all zeros would be males, and we could get now a frequency or a number of zeros. If there were 50 zeros, that means we had 50 males in our sample. If we had 25 ones, then we know that we have 25 females in our sample. And so it does not make sense here in a nominal scale to add or subtract or divide. And so when we're looking at the nominal scale, we want to keep in mind then that there is no magnitude with this scale. This scale does not have equal intervals, so no equal intervals. And this scale does not have no absolute zero. So relative to our properties over here, the nominal scale doesn't have really any of these properties. Just because you are a 1 females and males are a 0 doesn't mean that you're better or worse. You can't infer any magnitude here. It just means a category. and the differences between a male and a female are not necessarily equal to the distances or the same interval between 0 and 1. So the intervals between 0 and 1 don't correspond to the intervals or the differences between males or females. And there's no absolute 0 here. So a 0 under the variable x, which equals biological sex, doesn't mean that you are without sex, without a biological determinant of your of sex. So that just is our first stopping point here with measurement scales. So let's jump into the second one. The second measurement scale that we have is the ordinal scale. And the ordinal scale is really used when you have differing degrees of the variable can kind of be discerned. So when you can discern between different degrees of a variable, you can essentially then rank the variable from high to low or low to high. So let's go low to high or high to, let's back up there, high to low. So for example, one of the ones I use in class a lot is, we could, in a face-to-face class is you could put everybody in the room, have them stand up and assemble themselves in height, in rank order of height, from low to high across the back of the room. And so we could assign the tallest person, a rank order of 1, and if there were 10 people in the class, we could rank the, shortest person, at 10. And so that would cover everybody that was in the class. And again here, when we're talking back to our properties again, what do we have here? We have magnitude now. Magnitude, yes. Why do we have magnitude? Because now these numbers are commensurate with more of something or less than something. See, going back to the nominal, just because you had 1 that doesn't mean that you had more biological sex than somebody else that was also a 1 or a 0. Here, if you were a 1, you were the tallest in terms of height in centimeters, height in inches, whatever you want to call it. And 2, if you were a number 2, you had something less than that. So now we have this issue of magnitude. However, here, there's still no equal interval, and there's still no absolute 0. Okay? So let's just kind of continue to move this on here. I'll pull the screen down a little bit. So if we go on to the third measurement scale, the third one is our interval scale. And intuitively, you probably already guessed that's going to have equal intervals, but this is certainly a more highly refined form of measurement. I'll just jump into an example here. Let's look at temperature. We use this by way of an illustrative example. So if we have a temperature, the difference between say 50 degrees C and 60 degrees C is the same as the difference between, say, 90 degrees C and 100 degrees C. So the interesting point here is the 0 on the scale is arbitrary. That is, on a temperature scale, 0 degrees C does not mean that you are without heat. You're not in the absence of heat. You'd have to go to the Kelvin scale for that. So the Kelvin scale would be an example of what our next scale is going to be here in just a minute. But the 0 on these types of scales is arbitrary. So mass, somebody's mass of their body. If you were a 0, that means you would be without mass. Their height, 0 in terms of height would be without any height. And so those would also be examples of interval scales. So let's just talk about the properties again. So again, we have magnitude. We have equal intervals now. But here we have no absolute 0. Which brings us to, and I'm just going to go over here, our fourth scale, which is ratio. And our ratio scale, now 0 denotes the absence of the property. So here 0 equals no property that the scale is measuring. We still have the equal distance between numbers. It's interesting here that now we call this ratio because now we can look at with having an absolute 0 to kind of anchor us. What this allows us to do is take our observations and we can apply them as ratios or kind of percentages. And what this means is we can say, for instance, a 60-inch person is twice as tall as a 30-inch person. So we couldn't do that over here with our interval because we can't say that, say for instance 100 degrees C here is twice as hot as 50 degrees C because the 0 is arbitrary. It doesn't allow you to make that kind of ratio adjustment here. Whereas when you have a scale that does have a true 0, you can say, like for instance height, because 0 inches would be without height, you can say that a 60-inch person is exactly twice as tall as a 30-inch person. So what do we have here in terms of our properties? Well, we have magnitude again. We still have equal intervals. And our last one is now we do have absolute 0. So as we went from nominal to ordinal to interval to ratio, we continue to gain these properties, scalar properties. And it's probably important for us to understand that most of our measurements in the area of human performance or kinesiology research don't necessarily kind of reach this ratio scale here. It's just not often that our measurements are reaching that. Outside of mass and height, most of the time we're kind of down here in this interval piece. And sometimes we're up in that nominal piece. So that's it. I hope this gives you some intuition and some insight on at least how I think about the measurement scales, and I appreciate you watching the video.